Dear friends, welcome back to the channel. Today we'll be doing one machine on the one hub, which is order, perform a known plaintext attack to recover a repeating key, XOR key, and decrypt a hidden message. Before we get started, make sure to subscribe to my channel and give this video a thumbs up. It really helps the channel grow. So then, let's get started. Before we try to recover this hidden message, I'd like to explain one of the most basic knowledge in computer science and cryptography, XOR. I don't know how to pronounce it, XOR. And let me give you some examples, okay? Maybe I can use notebook. XOR, the operation will do this way. For example, like 1 XOR or 0 XOR 1. This will, will get the 1 because they are different. And 1 XOR 0, this also will get 1. And if 0 XOR 0, we will get 0. And 1 XOR 1, we will get the, we will get the 0. So let me give you the example in the real life. Imagine, we have two light switches. The light turns on only if exactly one switch is on. If both switches are on or both are off, the light stays off. So XOR operation works exactly like this. Okay? And this kind of operation has some, properties or natures. For example, A XOR B equals B XOR A, and vice versa. And if C equals A XOR B, and then A equals A XOR, B XOR C. So this is a very important property of XOR operation, or we can call it reversible. And we are going to apply this reversible principle to today's challenge. Okay? And also, I'm going to give you some, the computation example. Like if you want to, make XOR operation on two numbers, 5 XOR 3. So how to do? Before we try to make such operations, we need to convert it to binary. First, the 5 in binary is 0, 1, 1, 0. Okay? And the 3 in binary would be 0, 0, 1, 1. Okay? So then we can, we can conduct XOR operation. So the result should be, 0 XOR 0. This equals to, this equals to 0. And 1, the second position, 1 XOR 0, this will get 1. And 0 XOR 1, also we can get the 1. And the last one is 0 because they're same. So the result in decimal would be 6. Okay? So I think I have already explained XOR operation carefully. Let's go back to the loom itself. And here you can see we intercepted one of cipher's messages containing the next target. They encrypted the message using a repeating key. For example, key like key ABC is a key, and this key would be repeated because the message itself would be long. Okay, would be repeatedly used to encrypt the entire message. However, they made a critical error. Every message always starts with the header order. So I think we can copy and paste over here. And let me, we can start from scratch. We can new Python file. You can use any editor to code this program, like order challenge. Okay, and we do not need to import any modules. So how to do? And first of all, we can define the function. Although this is optional, we can define the keyword is def, and the name, for example, like XOR decrypt. Okay, and for this function, we can give two parameters or two values. The hex data, this one. This is the hex data in string. Okay, but also we need to give the second parameter or the second value, known-text. And in this case, known-text is order. Okay, so we can, because the order, we got the known-text, and also we can get the first part of the cipher message, and then we can recover the key. Okay, and the key will be repeatedly used for in the entire calculation, or in the entire encryption. Okay, so basically there will be two steps. The step one is to deduce key. Step 2, decrypt entire cipher message. Okay, so let's implement it in the block of this function. And so the cipher bytes, because we need to convert this hex data from hexadecimal strings to bytes. Okay, and this will be very easy. We can use the bytes and from hex, and we can give the parameter hex data. Okay, and next we also need to convert known text from the string, from ASCII to from the string to the bytes. This will be very easy. We can use the encode method. So known text encode UTF-8. Okay, so now we can deduce the key, and we can use the list, because for example, let's imagine here this part is the encrypted data of the order. Okay, and we can use this to XOR this part to get the key. Okay, so now, and this would be the list. So for example, like for C, comma P, we can use the zip function. This will return the multiple iterable objects. So zip, and so we can do the operation C XOR P. Okay, let's pass two objects to the zip function. So the ciphertext, and we can extract the first part from the entire cipher message. From index starts from 0 to the length of the key. Sorry, the known text bytes. Okay, and so I think so the cipher, and then we can need to pass. The second is known text bytes. Okay, but for now, this is a list of integer. We need to convert it to bytes as well. So we can use the function bytes. So now if you want, you can print the key. And then we can use use the key to decrypt whole message. Okay, so decrypt, but we can define the variable decrypted bytes. We can use the bytes array, but for now it's empty, and we can have the for loop for I in range the length of cipher bytes, the entire cipher message. Okay, and then cipher byte is, we can use the index cipher bytes, and the index is I. And the key, for the key byte, we can use, of course, we cannot use the same index I, because the I, the length of a key would be, will be smaller than I, right? After the first, loop. Okay, so we can use this way. So the should be key, and I percent length of key. Okay, not difficult to understand, I think. Then we can do XOR operation on those two things. We can use decrypted byte, and this can be done cipher and key byte. And then we can, because this is the list, so then, or array, then we can append this decrypted byte to this array or list. So decrypted bytes, append decrypted byte. But for now is the byte array. We need to, get the clear text. Decrypted message. We can use the decode. But if we have problem to decode, we can use this option errors to replace, and then we can return this decrypted message. So up to this point, we have already defined the function XOR decrypt, and then we can call this function. And but do that, we can use this way. We can, I think, hex data. We can copy from my notebook. So we can copy / and the second part. And you know, the known text is order, right? We can copy. So then we can call the function XOR. We can print the result of the returned value of this function. Okay, hex, data, and known text. That's all. So let me bring back the terminal window and run this program, Python order challenge. Okay, as you can see, we can get the key in bytes, and also we can get the challenge, okay, or decrypt the entire cipher message. So I think that's pretty much it in this video. Hope to see you again. Have a good day. Bye.